All right, hello, welcome to section 7.5. Chapter 7 has been on logarithms and exponentials, and now we're going to solve. Right, so in this section, we're going to kind of have two different types of problems. We're going to solve exponential, right, like where the exponent is a variable like this, and then we have log questions where it starts off with a log and an x in here. Okay, and basically the process, the biggest thing, which is why I whined and complained so much earlier, is that you have to know how to switch forms, right? So basically the way we're going to solve is if it starts in exponential, we're going to switch it to log form. And if it starts in log form, we're going to switch it to exponential. And that's how we're going to solve. A more detailed list of steps is you want to isolate it first. So like these ones, the log is already isolated or the base exponent's already isolated. But sometimes you'll have to like do something to get it alone first. Then you're going to switch forms, and then from there it's just boom, regular like algebra steps, and it should be okay. Okay, so basically in notes today, you can write down these steps if you want, or you can reference them on the PDF notes, and then more importantly, get the examples down. So, and I would start with like which form I'm in even. So like you can look at this one and think, are we in exponential or are we in log to start? So jot it down and then think about that. Okay, so this one's an exponential. I guess it says it right there in the start. That kind of makes it obvious. But also you can see our exponent is a variable up there, right? So basically we're going to switch it to log form. But before we do that, we want to get this base exponent alone, right? So the first step, if you haven't already guessed it, is to divide by 3. Okay, and now I'm going to see if you can switch forms. So I would pause the video and see if you can do that. Right now that we isolated the base exponent, switch forms. All right, so I'm going to write log, and then the little number down here is the base, so that would be the 16 here. And then log means find me exponent, so the exponent goes over here, and then this is our value. So we have log base 16 of 8 equals 3x. Okay, and so once we do the switch form step, basically we just got to figure this out on a calculator and then divide by 3. Okay, so this one actually I think I can figure out in my head is just 1/2, but otherwise, you can do that change of base formula where you do log of 8 divided by log of 16. All right, so here's what it looks like change of base. Log 8 divided by log 16. Oh, and I was wrong. It is not 1/2. It's 0.75. Look at that. First time all year I've been wrong. Just kidding. Okay, so anyways, and when you do change of base, just a reminder again that this number goes up, the number that's kind of already up high, and that one goes down low. So that's why it's log 8 over log 16, not the other way around. All right, so we just did that to get 0.75. Okay, and then we're going to divide by 3. So we get 1/4 0.25 as our answer. And as always, if you're not sure on these, you can always plug it back in, right? Like you could type all this in the calculator with x of 0.25 and see if it actually comes out to 24. It's a good thing if you're not sure. All right, so obviously this one's logarithmic, but we're going to then switch it into exponential when we solve. Okay, so this one actually is already isolated. I know we have a +1 and a times 3, but it's one big log. So you already have log equals 2. Okay, so you can go ahead and switch forms right away and think about what the base is. So I'm going to let you try to do that quick before I continue. So the base is an invisible 10. So when I switch forms, I'm going to go base of 10, exponent of 2, right? Log means find exponent, so this is our exponent. Base exponent, and then just put the value on the other side, and you can see how we're pretty much done now, right? 10 squared is just 100, then -1, and then divide by 3. Okay, and we get 33 as our answer. Again, if you're not sure, plug it back in up here, and you can kind of check to make sure that it's right. But this one, we started log and switched it to exponential form, right? That was the switch forms. We did it right away. Okay, and that's why that is so important. I feel like if you can get switch forms, right? Like once you get here, right, this is pretty straightforward. It's just the getting the switch forms part. All right, let's just keep doing some practice problems. This one is an exponential, right? So eventually we're going to be switching it to log. Pause the video, give it a shot. We've got to isolate this first. Here's our base and exponent. So this is what we've got to get alone before we switch forms. So it's just like 3x plus 15 equals this. So we're going to minus the 15 and then divide by 3, right? So I'll write it all out for you here, but we're going to minus 15 first. So that would be 81, I believe. Then divide by 3. So now we have the base exponent alone. Okay, so now I'm going to switch forms. So I'm going to do log with my base of 4, and then log means find exponent, so 3x goes over here, and then the value 27 goes there. All right, so now basically I got to divide by 3 once I do this on my calculator. And again, with change of base, the big number goes up, the little number goes down, so I do log of 27 over log of 4, and then divide that by 3. So log 27 divided by log 4. Probably going to get some wild decimal here. So we'll call that, let's just call it 2.4, make our life easy. Okay, so we get 2.4 equals 3x, and then divide both sides by 3. So that, I believe, would get us 0.8. All right, and that is it. That is our answer. All right, we're just going to keep going through them. So keep writing them down. This gets about as tricky as it gets here. So if you want to jot this one down, and then I'll help you at least with the start. All right, so the trick is you want to get a single log here, right, before you switch forms, right? We know it's base 10, even though it's invisible, but we want to get a single log before we do switch forms. So we got to actually use our properties from the other day. So basically, like, I can make this into a single log. When this is add, we multiply the 4 and x. Okay, and then the only tricky part about this is even before that, this 2 in front is kind of a mess, so I'm going to move it up. So this is those properties from yesterday, so I'm going to move it up there. So I have log plus log with no stupid 2 in the front anymore. Okay, and now I can write it as a single log, and I'm just going to multiply these two parts. So it's a log of 4x squared equals 2. And again, the base is like an invisible 10. All right, so now I've got it log isolated. Now switch forms. Okay, so I'm going to do base 10 power of 2 equals the value of 4x squared. All right, so hopefully you could finish it from there. 10 squared is 100. Now divide by 4, so you get 25 equals x squared. And then you take the square root, right? And this one's kind of a weird one because I think technically we should probably write plus or minus 5. Anytime you do the square root of both sides, get two answers. And if we're feeling a little queasy, I'm not sure if that seems all that right to me, but I could put it in. And actually, I'm not sure negative 5 is going to work here. Log base 10 of negative 5, that would be, log base 10 negative 5 would be, what is the exponent for 10 that will get us negative 5, which I think is not possible. So maybe the negative answer doesn't make any sense here. Changing my mind on the fly. Maybe the answer is just positive 5. That's getting a little in the weeds, but if you just got 5, call that good enough. All right, let me see what else we got here. Let's try 2 more. Let's do this one quick, and then we'll do one more that has the properties. So try this one quick on your paper before unpausing to see the solution. All right, so I want to isolate this base exponent and then switch it to log form since we start an exponential. Minus 2 would be the right first step to get rid of this 2 right there. Now I'm going to switch it. So I'm going to do log with a base of 3. And again, it's because this is all alone, I can switch it right now. So log base of 3, value of 81, and then my exponent goes on the other side. Okay, And then you can do change a base here to get this. But again, you could almost do this in your head because this is really like saying 3 to what power is 81, right? Log means find the exponent. So I think the exponent there has to be 4. But if you want, type it in your calculator, log 81 over log of 3. Either way, you should get 4. All right, and then subtract 2. And then divide by -2, so we get -1, which is kind of a strange answer. It makes me feel a little nervous, but you know, like that x is negative here, but if you check it, it should be okay because you're doing -2 times -1, which is 2, plus 2, which is 4. So basically you have 2 plus 3 to the 4th, and that should equal 83, so we can kind of check that our answer is okay. Okay, last one. Again, I'm just going to see where you're at. So I'd pause it and try it as much as you can before unpausing to see the solution. Okay, so this one's a log, so we want to switch it into exponential form. All right, but first we need to get this to be a single log. So the trick is we got to remember our properties from yesterday, which say if there's a subtract between them, you divide these two parts. So I'm going to divide, 6 over 3x. Okay, and then, I mean, you could switch forms right now. Technically, this would clean up to be 2 and 1. So maybe I will clean that up right now just to make life a little easier. That fraction cleans up, so it'll be 2 over 1. You could switch forms at that point, but I'd say make it a little simpler. Okay, so now that I have one log, I'm going to switch forms. My base is 10, so I'm going to do 10 to the power of -2 equals 2 over x, which is a little weird this side, but yeah, 2 to the 10 to the -2. Again, you can just use a calculator. But basically, it comes out as a small decimal, so it's 1/100th, like 1 over 100. But we can do decimals here, 100th. Okay, and then to solve this, since x is on the bottom, it's a little weird. But I guess the way I think of it is like times both sides by x. That's a little strange, but it'll cancel out the times x here. And so we'll get 0.01 times x on the left equals 2. And then divide by that 0.01. Okay, and I believe that that's going to come out as 200. And again, if you're feeling a little unsure, you know, put it in here and check. But I think the answer should be 200 here. Okay, I want to make sure I didn't miss anything. Sorry. Yeah, nope. So that's about it. Just a huge reminder is that get it alone first. Like on this, students want to switch forms, but make sure you like divide the 4 first, right? So I would do that as a decimal, whatever 3.5 divided by 4 is. So, you know, basically get that alone. So that was 0.875, I think, right? So do that first and then switch forms, right? Just don't forget, you got to get it alone first. That's the big mistake sometimes students make. All right, that's it. Thank you for watching. Your homework is likely out on Schoology for this. Have a good day.